Hey everyone, this is going to, one sec, this is going to be question number 8 on the discussion, and so it's counting evals and applies. And so what this function is doing, what this question is asking is that, we have our schema interpreter, and we have essentially what happens is that we call calc eval on some expression, and it's going to, do some stuff, as we mentioned before, with evaluating the operator, evaluating the operands, and applying the operator. So for example, we'll be applying the operator plus onto each of the elements 1 and 2, and we should get some result in 3. And that was kind of vague. I didn't want to give too much, but that's kind of the general gist of what we wanted to do for the schema interpreter. And so yeah, if you're pretty familiar with how calc eval and calc apply works, feel free to just stop the video, work through all the problems, and we can go over it in a sec. But otherwise, feel free to just watch on. And yeah. So starting off, we have the expression parentheses plus 1, 2. And if you imagine, this is inside the interpreter. And so what's going to happen here is that it's going to convert it to a readable format. So pair of plus all of that. You can imagine that, but I'm not going to write it all out. But what's going to happen here is after we convert it to that format, we're going to call scheme or calc eval on the entire thing. And so that's one operation, one calc eval done. That's when we call calc eval on this entire pair expression. And then what happens after is we always want to check the operator and evaluate it. And so our second eval call is going to be checking the operator. So it's a plus, and so that's addition, and we know that addition is not a special form. And so if it's not a special form, then we can go on and evaluate every single operand and then apply that operator using calc apply on each of the operands. And so what we're going to do is we're going to call calc eval on that 1. 1 is just 1. Call calc eval on 2. 2 is just 2. But we still call calc eval to get make sure this 1 is a 1, this 2 is a 2. And so so we have 4 calc eval calls so far. And last but not least, since we've evaluated all of our operands, what we want to do is we want to call calc apply. And so applying that plus operator on the 1 and 2 together, so that if you imagine if I had 1, 2, 3, calc apply would handle 1 plus 2 plus 3 all together. And so this would be one call to calc apply. So applying that plus operator on the 1 and the 2. And so so this results in 4 scheme evals. So remember that there's 1 for the entire thing, 1 for the operator, 1 for each operand, and there's 1 apply, so applying that plus operator on the 1 and the 2. And so that's going to be the first part, and let's move on to the next. And if you want a little more of an explanation, you can read that right here, this solution right here. And and so next up is this entire thing. And so this is a pretty similar fashion, still pretty similar to the previous thing. So I won't go into too much, but what happens is that we first have a call to the entire thing, calc eval on the entire expression. And then what we're going to do, we're going to evaluate the operator, and we see that plus is not a special form. So we can go about evaluating each of the operands as usual. So third call, evaluate the 2. Fourth call, evaluate the 4. Fifth call, the 6. Sixth call, the 8. And once we evaluate every single operand, what can we do? We can apply that plus on each of them. So schema apply. That's 1. And then we're applying the addition on everything. And so one thing to note is that 2 plus 4 plus 6 plus 8, it's 3 different additions, but we count this as 1 apply because calc apply is going to handle adding all of them together for us. And so this is only going to be 1 calc eval call. So whenever you have some operator on some operands, that's only going to be 1 calc apply call. And so so this ends up being 6 evals and 1 apply. So pretty similar to the last one, but we just have 2 extra operands, and so we're going to have 2 extra evals. And so this is the solution right here. Feel free to read it. But moving on, we have a more complicated thing. And so this isn't exactly new to what we've done, but we have like a bunch of like nested stuff, which can be pretty confusing. And so what's going to happen here, once again, take some time if you want to like work on through it by yourself. But what happens here is that first we have a call on the entire expression. And then second, we have a call to evaluate the plus operator. And then plus is not a special form, so we go about evaluating each of the operands. So third goes to evaluating this 2 operand. And then there's another call. There's another nested expression, so we're going to evaluate the entire thing. And then since it's another expression, we have to like go inwards. And so we're going to do the same thing. We're going to like call calc eval on that multiplication operator. We see that multiplication is not a special form, so we can go about evaluating each of the operands. And so we're going to evaluate that 4. 4 is just 4. But then here we see that we have another expression, another nested expression, the parentheses minus 6, 8. So we have to evaluate that, getting our 7th call. And then once again, we did the same stuff. So evaluating that minus operator, minus is not a special form, so we can go ahead as we want. Then 9 corresponds to evaluating that 6. 10, the 10th call, eval corresponds to evaluating that 8. And then we're pretty much done with like evaluating everything. And so going into this part, we evaluate like the 6 and the 8, and now we need to apply that operator, that minus operator. And so that's going to be 1 call, and this should correspond to giving us like a negative 2 out of it. But we don't really care for the point of this problem because we're just like counting the number of evals and applies. And then what happens afterwards is that for this expression, since we evaluated like the 4 and then like the minus 6, 8, we can go ahead and apply that multiplication operator onto each of those elements, operands, evaluated operands. And so that's going to be the next call. So that's going to be the second scheme apply. And then last but not least, since we evaluate this 2 and this entire expression, this entire big thingy right here, we can go ahead and apply that plus operator on everything that we just evaluated. And so that's going to result in a third apply call. And so in total, we're going to have 10 evals, and we're going to have 3 applies. And then, yeah, that's going to be the answer. And so here, if you notice, you can read this for a further explanation. But yeah, last but not least, we have this AND operator. And so this is a bit different. And if you want to take some time, go through it, feel free to like do so. But yeah, starting off, what happens here is that AND is a special form. So the thing about this is that, special forms are special in the sense that, we don't evaluate each of the operands immediately. And so, but in this case, I'm not too sure why we end up evaluating everything. But anyways, let's just go ahead with this. Yeah, so first we start with evaluating the entire expression. So that's a 1, that's our first eval. And then we want to check what AND is. Oh, actually, oh, okay, yeah. Okay, yeah, so we're going to check, my bad. And so we're going to check, evaluate what AND is. And AND corresponds like this AND function or whatever. And we find out that it is a special form. And so what we're going to do here is we're going to call like our special form function. And so yeah. Wait, let me think real quick. 1, 2. Okay, I lied. We actually are not going to evaluate this AND. And so the reasoning behind this is that calc eval works in the sense that if I see a special form, when we don't call calc eval to get the corresponding special form function out of it. We're only going to like get the corresponding function and call it on the rest of the elements. And so let me see. If I use the example right here, so in this case, this is our calculator function. But in the case, it's like pretty similar to your schema interpreter. But what happens here is that, so normally we want to call calc eval on expressions.first. So if we had like a plus, that's not a special form. So we're going to get that it corresponds to like the add function or whatever it is. On the other hand, if it were like and, what would happen is that in this check right here, we're going to see that it's a special form. And so with the special form, we don't directly evaluate the and get like the special form function and apply it on each of the elements. We're just going to directly call the eval and function. And so here we actually don't you have like eval call for all the special forms. We just go directly into calling it on everything. And so no eval call right here. We go ahead with like each of the operands. And so what happens here is that, remember that and is going to go on and on until we see, evaluate every single operand until we see a falsy value, and it's going to return it. And so starting off with the first one, we're going to evaluate that and see that it's just a value 1, and we know that it's truthy value, so we're going to move on. And what's going to happen here is we're going to evaluate this entire expression, and pretty similar to like what we did earlier, we're going to evaluate the plus, see that it's not a special form, and we can like evaluate each of the operands and apply it. So we're going to evaluate that 1, evaluate that 0, and apply that plus on the 1 and the 0. And so that's our first apply. And then, yeah, so the entire thing evaluates to 1. And then we see that, 1's not a truthy value. So we can, 1's a truthy value. So we keep on going through our and function. And last but not least, we call 7, our 7th eval on that 0. And it turns out, 0 is a truthy value. So in the end, we went through all truthy values, and we're going to end up returning 0. But it doesn't matter for the case of this problem. But then, yeah, and we're done here. And so what ends up happening is that we have 7 evals and 1 apply. And so if this and was some regular function, so if you imagine if it was like a plus, what would happen is that we would evaluate that plus operator and get the corresponding like add function out of it. And so this would correspond to 8 evals. And in addition, after evaluating each of the operands, so this turns into a 1, this turns into a 1, this turns into a 0, we would add all of those together by applying that plus operator, that odd add function on each of them. And so we would have 1 additional apply. So if that and was transformed into a plus, we would have 8 evals and 2 applies. But what ends up happening is that a special form, we don't evaluate that and operator, and we don't apply that and operator on the elements. We just directly call this special form function. And so because of this, we end up with 7 evals and 1 apply. And so, yeah, that's going to be all of this problem. And so I got confused on this problem myself. I actually kind of forgot that you don't evaluate special forms. And so if my explanation was kind of confusing, feel free to just like email me with like any clarifications. And yeah, hope you have a great day.